Okay. All right. So people who are watching this live stream, another in our exciting series of design reviews and software architecture meetings. Another internal meeting. This one is about our symbolic neural net framework. And it's a fairly detailed discussion that is about arrays and the handling of arrays in the neural net framework. So without further ado, let's get down to business here. Let me see if this is working. Okay, so NetSharedArray is what we're looking at. Is that correct?
Yep.
Okay. So let's understand what this is. Represents an array that is shared by more than one layer. We already looked over this at some point, right?
We might have glanced at it, yeah.
Didn't we already discuss? Okay, so, oh, wow. So this is some kind of, so what is the scoping of this thing? This is scoped within a particular net.
Yeah, it's global to the entire net. That's the point.
And so, okay. And what, well, let's take a look at what this, the value of it can be extracted with, okay, so what's the analog of that? So net extract can also extract a net port, is that correct?
Well, the port doesn't have a value as such in a just static net, so you can't extract a net port.
So what is the second argument of net extract usually? It's just the name of it's both the name of a layer and the, right? It has some way of referencing particular parts of a particular layer, yes?
Right. There's a hierarchical namespace for nested networks. That's correct.
So what is this? How does this relate to that?
Because shared arrays are global to the whole network, you don't have to drill into a certain part of the net to find them. They're a property of the whole net. So there's no list there to get to any particular point. You just ask for,
What happens if you want a subpart of the shared array? You just have to ask for it separately?
Yeah, that never happens to my knowledge.
Okay. Okay, so what is this net replace part? Oh, wow. Let's remind ourselves what net replace part. Within a layer, returning a new layer, replaces an array within a layer. So this is then replacing a global array. I mean, that's your concept here, is it's replacing a global array. But that's, wait a minute. NetSharedArray is something whose value is defined at runtime, isn't that correct? It's not a static object.
It is.
What do you mean it is?
Well, like in a convolution layer, for example, the weight and bias matrices, they're not runtime properties.
No, I understand. Okay, so those, but okay, so this is so it's simply wrong that this is a runtime property. Is that right?
Yeah, it's wrong. Yeah.
So
all this really is, it's simply it's a one level of indirection in the way that arrays can be used in the net. That's all it is. It's a pointer.
Well, but among other things, it means when you train that two arrays at different places in the net are locked together. Is that correct?
That's true.
Okay. Specified any ordinary array of a layer such as blah, blah, blah. I mean, this seems fairly uncontroversial, he says.
Do you want to look at some examples?
Yes. Is it controversial? Is there something I'm missing here?
Well, it feels like a fairly obvious design to me. And when I showed it to...
Here's an issue. If you've got modules in a network and they have net shared arrays, then the namespace of those modules might clash.
What is a module?
Well, I mean, so let's imagine that you've got a repeated unit in the net. Let's say you've got a piece of a net from the neural net repository and you're gluing it together with a piece of, you've got two nets from the neural net repository, right?
Right.
And they both have shared arrays in them, but their shared array names clash.
Yes.
How do we deal with this?
I think the way that we'll be forced to deal with it, and there's no, I mean, you can deal with it manually in that you can rewrite the shared arrays to be unique names. But I think the way we'll deal with this is a tool that is kind of the opposite of the second function in our agenda, which is what lets you easily take a giant network and share everything inside the network. So all we really need to do is, once you've created such a shared network, is to like remap all of the names in one fell swoop.
Yeah, but how do you do that? Because I mean, you've got both networks have a shared array. You know, we've got two networks that both have a W shared array, right?
Yep.
And then we net chain them together. And how do we know which W is which? See what I'm saying? Well, the information is lost by that point.
Well, it'll fail at the point that you try to join them together, because it'll say there are two shared arrays called W, and they have different values. I can't merge all of this global information into one.
I don't understand how it would know that. In other words, what you'll see is, let's take a specific example. Okay, let's imagine we have a net chain of a couple of linear layers. Okay, like this. And, just two of those, fine, all good, whatever. Okay. And then I simply am taking, well, whatever, that got confused because I didn't know what NetSharedArray is. But then we're simply taking.
Do you have Proto? It will work on Proto.
Okay, well, let's do it. Come on, wake up. Okay, but you understand what I'm saying? I mean, how would it know? I just take these net chains and I chain them together. How's it going to know? Where's the error message going to occur?
Yeah, I fully understand, and there is an answer to this. Before they've been initialized, if they are the same shape, then a clash is not a clash. A clash is actually the ordinary behavior. Clash is what you want. The whole point of these things is to clash. That's what sharing means, right?
No, but not if they're no. Look. You've got two different modules. I'm calling them, right? Two different nets, and they both have shared arrays in them, right? The shared arrays mean completely different things in the two nets, right?
It's specifically mean different things means that they're unshareable, right? They're different shapes, or they have different actual concrete values in them.
No, they have, one of them is, they happen to have the same shape, but one of them is, something for some attention layer somewhere, and the other one is something for some random, I don't know, some, feature extraction layer. Okay. Sure. But they happen to have, compatibly, they both happen to have the same shape, and they both happen to have the same name in these two utterly different networks.
That's going to be an edge case. The answer to both of these things is the same, which is that you remap them to be unique with the function.
What on earth is that crazy thing that has some kind of medieval motif going to it?
That's a placeholder, but design has not gotten back to us yet with an actual icon to use. So
who's working on design?
It's assigned to Jeremy Davis, and he delegated to somebody, but I can't remember offhand.
Do we have a PM here who would know?
I mean, Sushma did remind, and I reminded today. I said, we need this soon.
But we kind of need it this week, right?
Yeah.
Do they have any idea what kind of a thing they should be using for this? What was it before? What was this icon before?
There was no icon before. It wasn't collapsed before. It was just always the full expanded set of layers. And for small things, that's fine. But for big things, it's crazy.
I kind of like the big expanded version. Are we sure we want to compress it by default?
I really think so. People in QA are very happy about this for what that's worth. I mean, they have to deal with a lot of nets, so.
I think it always looks impressive that there's all this code for a net.
Yeah, except when if you look on the repository resource pages, the same net gets duplicated a dozen times, and it gets tiresome seeing a 40-layer network 8 times.
All right, let's get somebody from design, because we don't have that long until the end of the week. Let's see if somebody can just join us right now.
Okay, I'll grab somebody.
Okay. Okay, in any case. All right, so the point that I'm making is if I simply net chain two copies of the same thing together, right? Then we've got something kind of crazy happening, right?
It's not actually crazy. Like, it's fine. All four of them share that array. That's the desired behavior. If you don't want that, then you need to name them differently in the two different branches. And
so this funky creature, like some kind of, it has some kind of, I don't know, why am I reminded of a bat symbol or something? But I mean, that's your notation for a shared array. What's that?
We should design that. I mean, it could be a color or just something to indicate it's an indirect. The value is not there. It's hiding in the global scope.
But what about the size? You're not giving the size here. Is there a place where you're giving the size of the shared array?
I could try to sort of shunt that size along there, but you see, okay, this should have gone on the agenda, to be honest. There are some questions.
Jeremy's coming in.
Question one is, in ordinary, like if you open that original linear layer, the one with the shared array in it, you'll see that, no, the linear layer on its own, not the chain. The very first thing that you started with.
This thing here?
Yeah.
Okay.
Just copy it out. Copy out
what?
In the input form, the linear layer 2 weights goes to NetSharedArray W. Just copy that out and evaluate it. If you expand that, it's a bit silly to share. It's not sharing with anything, so it looks a bit silly. But you see there's an arrays section and there's a shared arrays section. Shared arrays are global to the network, so they're always at the top level object. In this case, that top level object is the linear layer itself. Now, where do we put it in a net chain? We do want to say there are a bunch of ambient shared arrays, but it's awkward to like put them. I mean, do you put them under the list of layers? I'm not really sure where to put that.
Well, I'm thinking. I mean, so at each particular layer, it seems like if you're going to do this for a single instance like this, you've got to do it again here. You've got to say arrays and shared arrays here. You're saying parameters, arrays, shared arrays for every layer. Right?
Why?
Because, I see what you're saying. You're saying this is a pure shared array, which is global, and you're already declaring the fact that the weights are corresponding to this shared array. I mean, clearly, okay. Yeah. I mean, obviously, in some clickability type sense, you should be able to click on this and it should open out the specification of the shared array.
Okay.
But I don't quite, that's not solving the whole problem. By the way, did Jeremy come?
Yeah, I'm here.
Okay, we're trying to avoid medievalism with this crazy chain.
Okay.
What are the other icons? There's also a net graph icon. Is that correct, Tally?
Yes, that's correct.
And meanwhile, we've got this funky icon here. What other icons do we have running around in the neural net world?
Those are the three.
Okay, so we've got an icon here for an uninitialized. So actually we've got four. Okay, we've got the uninitialized. So if we do a net initialize here. Oh, great. I don't know. What do I do here to make it?
Input goes to 2, for example.
Okay. All right. So now for a convolution layer, do you have the same icon or not?
Yeah, it's all the same. I mean, it might be nice to like elaborate that out into a whole zoo, but like we got bigger fish to fry at the moment. But I did think it was weird to reuse the layer icon for the containers. I think it's nice for the containers to be somewhat distinct.
In this case, is the layer actually a node in that graph?
No, the layer is actually, the layer is the interconnections. It's a matrix which defines these interconnections.
Okay.
But I mean, frankly, some layers are really not very convincingly like this. This is a good representation of kind of the classic old-fashioned 1940s neural net that is the linear layer.
Yeah, but a flattened layer, for example, it's kind of a bit gimmicky to have a little thing there. So it's more branding.
What is a flattened layer? What does it do?
It just takes an input tensor and flattens it into a vector. There's no learned parameters or anything in there.
It might be nice, by the way, to distinguish layers that learn from layers that don't learn.
That's true. It's like maybe an F, like a curly F or something for just non-learny layers.
What the heck does that mean? Stand for fixed or something?
What is that? It's a function rather than a learned thing.
Nobody will ever figure that out. You mean an F instead of this thing here?
Yeah.
How would you indicate learnability? Don't tell me a picture of a brain. How would you indicate that something can learn? You indicate the calcium channels of the synapses by having little dots. No. But okay, so what we've got here potentially for individual layers, we've got the fixed layer.
That uninitialized is very useful to have on the chain and on the graph as well. And the way I'm doing it is it's programmatic. It just literally grays out the icon and puts the text on top. There's no difference.
Cannot possibly be doing that because maybe it is. Yeah, maybe it is. Okay. Yeah, I agree that seems obviously useful. So it's got to, so that's a constraint on these icons. Okay, so to me, NetChain, when you see pictures that people make, which are probably only a temporary phenomenon in papers of neural net chains, they usually have these things that look like kind of leaves, so to speak. What am I talking about? Let's see. Let's take a look here. Let's, well, okay, so let's look at a typical, okay, so these are the typical images that people use for just the standard network. But then what I'm looking for is, what am I looking for? You know what I'm looking for? The thing where you have a series of kind of book-looking things, one going to the next. A little bit more like this. Am I making sense?
Yeah, yeah.
Except that I think, Tally, Sebastian, what do you, I mean, yeah, this is more, this is like this is like the chain, right, guys?
Yeah, that's a chain.
And what would be a representation of a graph? I mean, it's a little bit more like this kind of a creature.
So there is one popular one is TensorBoard. So if you just type in TensorBoard, it has various graph visualizations.
No, but we're talking about an icon for the summary.
Yeah, okay, fine. Yeah, it's not exactly. But he was asking like what it might look like.
That has nothing to do with this.
Like the one on the right, top right.
But I mean, we need something that's like basically.
Yeah, no, it's not exactly. It's not a representation of a.
No, I mean we've already got this type of thing.
Yeah.
Can you evaluate a net graph just to see what the existing thing is? Because it's not a bad place to start. It's really not aesthetically good, but it's not.
Okay, well let's go to the neural net repository and I can find one.
Or just do net graph of ramp.
Net graph of what?
Open list ramp, close list, and then open list, close list. So it's only got one node in it. Just ramp on its own. Doesn't have to have an argument.
Like this?
No, ramp the symbol, not applied to anything. And then close list, and then open list again for the edges, and then close list. Yeah. So that's the little icon
that you just made.
I just made it. It's a placeholder. I mean, there's a ticket's been open for a couple of weeks.
Well, at least it's not medieval.
It doesn't look much different than a layer, though. I just don't see that it's bigger or somehow more of a parent to the layer.
Right. I think what we need to do is indicate is have something more like those kind of blocks that you see. These are dots representing individual connections, so to speak, individual ports in the network, instead of having something which is much more like, in a sense, we can imagine this whole gray area here, this whole gray slab, that represents a layer, if you understand what I mean, or something, right? And that then it's kind of a collection of slabs rather than a collection of individual, connection points. Did that make sense? So that what I'm imagining is that we can do something where we've got.
Do you have that that camera that lets you draw on paper?
Yes, I do.
That'd be
clear my desk up slightly to be able to use it. Hold on 1 second. And I have to get a pad of paper. It's not something I necessarily have. Here we go. Okay, let's do this.
I do like the idea of blocks, though, rather than little dots, because it emphasizes that the object, the components they're not neurons, they're entire layers.
All right, so what I was having in mind is something more like, except that it's a pity that this is vertical, whereas the actual, net thing is horizontal. So I mean, I was thinking of something, maybe more like that, maybe, with dashes at the ends to indicate the chain, and then maybe something more like, I don't know, something like that to indicate a graph.
I like that.
Jeremy, your comments?
I think I need to work with the top one. It looks pretty simple.
Well, I'm thinking that those would be gray blocks there. I mean, it's not going to be a big icon anyway. Mm-hmm. The only thing that bothers me is that the actual thing is going sort of down the page and this is going across the page.
Yeah.
I mean, we could flip it around, although I think, what do you think about that, guys?
Well, I experimented a little bit with a couple of these little ideas. The going down doesn't work, and the reason it doesn't work is that when it's collapsed, it completely disturbs it kind of needs to be that wide, that
but
aspect.
You're saying the aspect ratio can't be. Okay, let's let Jeremy.
But Jeremy, do you see that there's two, right? The chain of the graph.
The second one, you kind of have this half arc here. Are the shapes important?
No. So I didn't mean that. I meant every one. That was my rectangle, right?
Okay.
I was meaning every element is a rectangle there.
Okay.
So in other words, to distinguish, there's rectangles for layers and there's dots for connections.
So graph is a connection of these different layers.
That is correct. So the big, the bottom one, sort of the big version of that is, so to show you an example of a real one, let's just pull one up. Where's a typical thing that is full of graphs? I don't know. Does Inception have graphs?
A lot of them are factored to be net chains. Okay, but you know what's a very nice graph one is? Yeah, you know what's a nice one is Jerome's question answering net.
Is it on there yet?
It is. I just don't know what it's hidden.
There's also the restyling one as a graph.
Wait a minute. This has a graph here. By the way, when are we going to get rid of those angle bracket number things and make that?
Do you want to? I kind of like that you can see how many nodes they have in them.
Well, yeah, sure. I just think those angle bracket things are really ugly.
Okay.
I mean, how can't we? How much control do we have on what those look like? Are those short indicators or what are those?
No, we have infinite control. Just tell me what you want them to be.
Jeremy, spec what they should be. I mean, they could be a 23 with two gray blobs on either side of it, or dots with 23.
That'd be okay. Yeah.
Just screen cap that and just give him some simple thing to,
Okay.
Okay, but if we click on one of these net graphs, that's a really boring one. But Jeremy, you understand these can be arbitrary graphs.
Yeah. Okay. I just didn't understand what each of those dots were. So in that case, each dot is a layer.
Each dot is a layer. Yeah, each dot is a layer. So in fact, in this iconography here, this iconography is bad. In other words, the meta iconography should be a connection is a dot, a layer is a rectangle, which means that in this diagram, Tally.
Yeah, I realize we should change those to little rectangles. That's not impossible.
I wouldn't have thought so. Or squares, worst case.
Yeah.
But rectangles would be better.
I mean, diamonds would work here?
What's that?
Diamonds would work in the illustration, I think. A stack of diamonds gives this kind of arrow flow left to right, which would be nice.
What do you mean by diamonds? I mean, do you mean...
Well, yeah, so square just turned on its side, and so it's, as you stack them, it's kind of this diamond shape.
Not so keen on that, because there's a thing going. People pretty often illustrate neural net layers by these rectangles.
Okay. All right.
Yeah, so then in this, and by the way, these colors are really, where did these colors come from?
I'll show you the whole table, and if you, I mean, it's very hard to optimize them. When you see the whole table, it's very hard.
Why don't you send me the table?
You want to do this now?
Well, or just bring it up on the screen right now. Do you want to share? You can bring it up.
Let me find it first.
Okay. All right, but I think we've got I mean, I want to say that I like seeing. Okay, so when in the closed state here, I see layers 24 input, output class. Well, that's fairly reasonable. It's fairly reasonable, unless we wanted to display the 24 layers underneath here. Probably not. This is fine. Okay, so then this net chain, this will look quite reasonable, I think. Jeremy, could you maybe get some version of those icons in? And remember that they've got to have the word uninitialized. They've got to be able to be grayed down and have the word uninitialized painted on top of them like this.
Okay. Or underneath, right? It wouldn't have to be on top necessarily, right? But gray is important.
Yeah, I think on top is nice, and I don't see a real problem with that, even in this case. In other words, just seeing, if all you see is the top and bottom of those rectangles, that seems fine to me.
Okay.
Okay. Anything else we need from? Oh yeah, you were going to show this color palette. Tally.
I got distracted. Sorry, I was just staring at your screen. Almost there. I better mute so you don't hear me typing.
Oh, here's an example somebody just sent through of a typical. Yeah, that's a typical kind of what people show for a neural net.
Okay.
Okay, so we're showing something that's a bit more iconic than that, which I think is the right thing.
And this is particularly for convolutions. Like it's showing the number of filters and all that. And
yeah, I mean, there's a certain argument that we should be able to make diagrams like this. I mean, I don't know whether these diagrams are going to go out of style as networks become more complicated. I mean, it makes me think of, back in the day, well, when people used to use flowcharts for coding, so to speak, right? They would have a visual representation of things, but that really fell apart when coding got more serious and complicated. I haven't seen people use flowcharts, back in the day, for an ancient person like me, right? Before you started, typing up your cards, you would fill in a flowchart. Nobody even finds that. Nobody even knows that was a possibility. But anyway, people stopped using flowcharts, right, as their pre-coding activity. And I suspect they'll stop using these diagrams as neural nets become more complicated. I don't know. Do you want to comment on that? Tally, Sebastian, any comments? No.
Yeah, I mean, I've seen for very specialist sort of things, they make these diagrams. I'm not sure how we would generate.
Yeah, right. I mean, okay, whatever. I think they're going to go out of style. I think we just.
Yeah, I agree with that.
Okay, so in the chat, there's tiny, pretty simple. You'll see you can get a little table of the colors. I've tried to go with
here
in the Zoom chat. Just copy out the last line of code and run it, and you'll get a table of the colors.
The last line, this one here.
Well, it'll work, but it's more complicated than it needs to be.
Okay, well, let's get the last one. Okay. 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 So how did you pick these colors?
A couple of things. Like when you make a loss net, like here's a random example of a kind of principle. When you make a loss network, the focus is the loss layers. So you want the loss layers to be as kind of bold and stand out from the others as possible. And that's why they're very primary-ish colors. Cross entropy is cyan, mean absolute and mean squared are sort of pink. Another thing is it's not that common to mix things like mean absolute and mean squared in the same network. So it's okay if they're very similar levels of pink. Like you're not usually going to need to distinguish them.
Okay, so question, guys. Okay, so here, if we look at, You know, it will be really good before the fold to have some idea, in addition to layers, which is just for the net chain, it will be good to have some idea of what the total complexity of the network is in this before the fold object. How can we give an indication of that? Sublayers, total weights.
Yeah, we could have arrays, colon.
Okay. And what would the answer be here? A ton of them.
Yeah, it would be very large.
Well, that's fine, but that's okay. That's good because that gives an indication right before, you know, at the fold. I mean, to me, does net information give a bunch of information about this thing?
Oh yeah, plenty.
So if I say net information of this, can I do that?
It's not documented, but you can.
Oh, well, that's because it was not the right place.
Actually, it's broken. Yeah, it's broken because you made me change the names, and I forgot to change them in the automatic thing. But it's not even documented, so.
Okay, well, we should make that. Shouldn't we document that?
I don't really want to because we have to introduce a new symbol, net information object.
Wait a minute.
Like,
so how does one use net information right now?
There are two arguments.
Okay, what's the second argument?
It's the property or properties you want.
Okay, well, give me an example of property.
Layer count. Layers. Oh, sorry, I was just looking at the thing there. Layers count.
Okay, so that doesn't agree with the. I mean, how would we indicate this? Okay, so give me another one. Like weights. Is there a weights count?
There is arrays count.
Okay, what about total weights?
What does that mean? Total number of elements.
Total number of changeable parameters in the network when it trains. How many weights are you training?
Yeah, I mean, you chose this name, arrays element counts.
Arrays elements count.
Element counts.
Elements or element?
Element counts with an S. I will double check that that's in the documentation, but I think that is the exact thing in the documentation.
Okay, but that's, what about the total of all of that?
Oh, total element count.
That sounds sensible. Total element count?
Arrays total element count. You've got to keep the prefix.
Okay, that's an interesting number, don't you think?
It is quite odd to pick that out as being uniquely important.
Well, I know, but we could pick 2 or 3 things there.
Okay. And so then the net chain gets a little bit higher. I suppose that's fine.
Well, I mean, I'm saying that, yes, I'm saying that the closed net chain or any, okay, so this would, so what is the information? So we can say layers, and then we would say total arrays, total array elements. I mean,
okay.
I mean, where could we put that? Are we putting that underneath? Well, it would be nice to put that somewhere.
No, the bigger challenge is what happens to it when you click the plus, because what's nice about the current thing is that input layers output is basically an elided form of that table. You've preserved the first row and the last row, and you've just elided all the other rows. But now, if we have 2 different kinds of, we've got 2 different kinds of table.
Well, what about putting it underneath the left-hand side here somehow, or underneath the whole thing, and it kind of goes away when you open it out? I think this is very useful information. I mean, this gives you a sense. Is this a little network or a big network?
I agree.
What are the other? Okay, so okay, hold on. A couple of different things here. I think net information with 1 argument should work.
Okay, look, it's an executive decision not to support that because there's so much actual like high value stuff to get in before the freeze.
Yeah, all right. Okay, well that's fine. All right. That's fine.
Page.
If you can undocumentedly put it in, that would be great. And maybe we can loop back and document it later. Okay.
All right. Sure.
Are you going to remember to deal with that? That is to loop back later. Can you send mail to, if Sushma is PMing this, Could you send mail to her?
Okay, sure.
Okay. All right. So, and should we get Sushma in this meeting if we're doing a bunch of things that involve?
She's currently out.
Oh, okay. That's why she isn't here. Okay. All right. So let's loop back to this for a second. All right. So what I think we want is a design for this thing that has the books, the book image there. Then I don't know whether in these blobs it is conventional to run something, we could have a separator line in the blob here, right? And then run across full width. We could run total arrays 416, total array elements, blah, blah, blah.
Well, take a look at flatten layer. Because a lot of layers, in fact, all layers have different sections to their summary box. So click the plus.
Okay. Okay. So we could easily have a separator like that.
Yeah.
Okay.
My only complaint is that I think it starts to get a bit too heavyweight when you're dumping this kind of information into the closed form. I think the open format would be great.
I think it's really useful to have it even in the closed form. I'm saying it really isn't very helpful. I mean, this looks like, oh, we got a little network here, but actually it's a great big network with 14.7 million, array elements.
Okay.
I mean, that's really useful to know. It's a big hunking thing. I mean, my preference would be if this thing could go full width, but I don't know. Jeremy, do you want to comment on whether that would look reasonable, or you think this is better to do this?
I was in Photoshop, so I didn't catch the end.
Okay, so the issue is if we're putting in this array, total arrays, total array elements, does it go on the right-hand side aligned like this, or do we go full width?
What point don't we go full width on some of these pretty soon on these cases? And when do you start to see the actual graph? Yeah.
Well, we go we go full width there.
Yeah.
All right. Look, Tally, why don't you see? Maybe you can do it this way because it's easier to do right now, and just put in. So those are the parameters we want then: total arrays and total array elements. Actually, we could say total array, just to shorten it, we could say there, total arrays. I don't know whether we capitalize. Do we capitalize the second word? I don't know.
Okay, but I have a suggestion.
Yes.
You've neglected the total layers, which I think is also very interesting because it tells you how substructured it is. How about this? Layers, 24 bracket 400 total.
Okay.
And then what do we do with arrays? It's not quite the same thing.
I don't think that's going to work.
Sebastian, do you have any opinion about this stuff?
Not much.
I mean, the other possibilities, we can say totals. And then the problem is if it's a pure net chain, we could say totals, layers 24, arrays, blah, 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 elements, blah, blah, blah. That seems useful, right? If we can do that, if the totals is some other, thing like this, makes sense?
And then there's also shared arrays. And if there are any, shared arrays goes to.
Well, let's not worry about that here. This is an overall indicator. We don't need to know how many shared arrays there are.
Okay.
This is, I think, whether you count shared arrays as distinct or not, it doesn't really. I would say count shared arrays as distinct, but in the elements have them. This is the number of independent elements, so to speak. Make sense?
Okay.
All right. Let's try and get this together and okay. Hey, Jeremy, are you actually designing something, or
I am, but I'm not that happy with it yet. I could show you what I have, but I think it needs some work.
Do you want to keep going for a couple of minutes, or?
Yeah, sure. Yeah, it might help.
Okay. And although just one, could you pay attention for 1 second here to
Yeah.
these crazy colors? So first of all, these are the colors that are being used in these graphs here.
Okay.
I consider these graphs to be somewhat ugly right now. Do you think, so rectangles instead of the circles, I think they'll look okay. Do you agree?
Yeah.
Okay. Question for these colors. Do you have any opinion about the color palettes here?
I'm looking because there's a lot of colors there. I certainly see ones we could improve, but there's just so many.
Well, could we just use one of our standard color palettes?
Yeah,
I've tried. It's really bad.
What's that?
It's really bad.
I've tried. It's really bad. The thing that we can design these, we can tweak these. There are useful constraints here that we should try to preserve. Like, for example, losses are from a similar part of the spectrum. Things that are typically not important are dulled down. Like structural operations are typically dulled down because you don't really care as much about them.
All right, but so you've already done a bunch of work on this, is what you're trying to say, and what you're claiming is that, like, are losses in the red somehow?
Losses are almost ugly. They are primary. They're so distinct from the rest of the thing that it's very hard to miss them. I think that's a nice property. I mean,
well, being ugly doesn't seem like a great property in and of itself, if I might say so.
Sure, but they're attention grabbing. I mean, they don't look like any of the other colors, which I think is important. Structural operations have like an orangey already twist to them. Things that are like batch normalization have the same kind of salmony color, like instance normalization, local response normalization. All the normalization things are roughly the same. Convolution pooling, and like I've tried to cater to a couple of different common motifs. Like convnets have this repetition of blue, green, light green, blue, green, light green, because they've got pooling and convolution, and then
All
element.
Right. Look, I think we've got bigger fish, even notwithstanding the salmon business, we've got bigger fish to fry.
Sure. Oh yeah, RNNs are also from the same kind of spectrum. But like, if we can keep those kind of ideas and completely, I don't care about the colors so much as those ideas, you know.
All right, but the other thing we have not addressed is your statement that we might want to get for this icon here, and that would then affect the icons that I mean, in other words, you could have 3 or 4 categories, and those could also be reflected in different icons in the closed layer representations, in the layer summary blobs. Am I making sense?
Yeah. No, that would be nice. But it's,
I mean, it's also, one could imagine, although perhaps it's not a good idea, having some, having that color inform the color that's used here. That is, given that you're really using as the summary of the network, that you're really using, and I don't even know, if you want a top level graph, how do you do these colors show up anywhere else? If you get a graph from the net graph, do the colors show up in the node colors and things?
I don't think they do. I mean, I suppose they could.
Okay, so look, the thing that we can imagine correlating is the, some coloration in these summary boxes, coloration in the summaries inside the openers, and what happens when we actually build the whole network. Because it would be nice to have a standardized way to get some easy visual representation of the whole network as a graph. But I think we should loop back to this. This is not a problem we have to solve today.
Yeah.
Let's just get these icons for today.
Yeah.
I mean, if we're going to introduce these things, this is going to cause all kinds of problems with that means the neural net repository pages have to be regenerated with these things changed, right?
Yeah, that's already the case with all of our documentation. I mean, yeah.
Okay, but often we will want to have the first instance open on a given page.
That's a very good point. The first instance open and then subsequent ones closed.
That's what I would suggest.
Yeah.
That's what I'd suggest. That's for Megan, I think.
Maybe Sebastian can make a note of that for Megan.
Okay.
Sebastian?
Yeah.
Okay. All right. So, Jeremy, just let us know when you're ready to show something, or
Should we go back to the shared arrays for a moment, or
we need to go back to shared arrays. Okay, so it is less than perfect that there's going to be this clash. I mean, there's no scoping of these things.
Yeah, but I stick to my point that no scoping is actually why they're useful. The whole point of them is to clash. But if they clash,
how do you know if they clash? I mean, okay, you're going to produce some message if it so happens that they don't agree in size. Okay.
Or if they already have concrete like most of the things from the repo will be trained, and then even if they happen to agree in size, there is astronomically, there's a zero probability.
Right. And you're going to know. So what's it going to do if it sees two networks being net chained together, and they have, shared arrays that have clashing names but are different shared arrays?
It'll say, I'm not sure if it does this yet, but it absolutely has to by the time we ship. It'll say the shared array with this name is being used in two different places, and they have different.
So I'm going to make a suggestion that generate a warning that says that, but rename the things.
Okay, yeah, that's possible.
Add a 1 or something.
1 and 2, yeah, if they're in a join or whatever.
Right. So I think that's the useful thing to do. But you got to tell people you're renaming the thing.
Yeah.
I mean, it's obvious you should rename all of them. It's possible you should rename after the one that happened to be first in the sequence. You see what I'm saying? So in other words, if you've got W and W, it becomes W and W1.
Okay.
My suggestion, maybe I'm wrong about that, but I think that's a better idea because most likely, it seems like a better idea.
All right.
Okay.
It does suggest a function as well, which is rename shared arrays.
Oh God. Okay. Well,
because I want to point out, this is actually pretty much the same story as you have with net rename layers. If you have two chains and they contain...
I didn't even know there was a net rename layers.
You reviewed it at our last design review meeting. Do you want to bring up the doc page for it?
Yes. What a horrifying thing. I mean, by the time we're doing this, see, the problem is, okay, we've got such a similar framework, for example, for quantum computing. And I just profoundly hope that we don't have to have, quantum rename, operator or something. You know what I'm saying? But
yeah,
this is a bridge we can't yet cross. So I mean, we're protecting names. Go ahead.
You reminded me of something, which is that there's that what is that thing called? Clashing function, or what's it called? Conflict.
Combiner function.
No. It came up when your son suggested the third argument to key map. Remember that?
Oh, collision function.
Collision function. So collision function would be a natural function to have for all the joining operations that could introduce a conflict.
Yeah, that's a good idea.
But anyway, rename layers exists for other reasons too, which is like, one would be you import a net from some external source.
Are we going to remember the collision function thing? Because it's a decent idea, but it's not something we have to introduce today.
Yeah, I've made a note of it.
Okay. Okay. All right. So I was going to look up net rename. Oh gosh, this prototype build DocuTools bad interaction is really annoying. Net rename layer, right? No, what is it called? Net rename layers. Yes. Oh, look at that. The word renamings needs this as a spelling word. I'll send it in. Okay. That is not a very inspiring, I mean, it's not properly knitted here.
No, none of the docs are.
Okay. Rename shared arrays.
That's for after the freeze.
I mean, there's a certain argument that you could just have a net rename function that can, I don't know, that could rename a bunch of different things. It's a wimp out to call it net rename shared arrays. Eventually, I mean, these are still experimental functions. We can still think about
It's still
merging.
unified. Yeah.
What's that?
Yeah, we can wait until the framework is kind of completely stabilized in its feature set, and then we can try to unify.
I suspect they can be unified. Okay, so the next question was how to display the shared array information, right? That was your next issue. Is
Right.
in a chain, how do you display the shared array information?
Yeah.
But so do you really want to show at this level, do you want to show the shared arrays? You're not showing any arrays at this level.
We're not showing any arrays, yeah. The reason that you want to, I think you want to show shared arrays, or at least the presence of shared arrays, is that otherwise there's no way to know. It's like you introduce a shared array and it gets swallowed up into this black hole at the global scope. And you just don't, like, where did my array go? You know, like, where is it? The fact that it exists is not visible to you.
No, I understand that, but you're saying that the manifest of what shapes the shared arrays are should be somewhere, right? And so here you are saying, you know, this is the shared array, but you're not giving the information on the shared array here, which I personally think is kind of annoying. I mean, that is, if I'm looking at this big network and I'm drilling down and it's like, okay, that's a shared array, great, but still, I don't want to have to indirect to find out, you know, how big that shared array is. I would like to see it right there. That it is shared is useful. It's like, you know, you see when you do an ls-l or something, it'll show you something as a symbolic link, but it'll still show you the size.
Yeah.
You know what I'm saying?
Yeah. Okay, I can add that. Then do we drop? Well, let's figure out the sort of typography of these shared arrays, because the box thing is just complete placeholder I made up.
Right. Okay. Well, fine. So you've got the name of the shared array. I mean, it's really shared as weights or something, or shared array. See, I'm thinking you want this exact same thing, matrix size, blah blah blah,
Right.
and then paren shared. But you've got to say what it's shared as, right?
Or you could put the shared as on the left, or you could say weights and then arrow matrix. I don't know if there's a link. Is there a link icon we can use or something?
Well, what are you suggesting? You're suggesting that we make this much wider by giving the weights information here.
It's going to have to be wider if you want both the shared.
Well, it can be multi-decker, or is that not doable?
No, that's doable.
Okay, then my suggestion would be something like on the next line to put wherever I was doing this, to put something like on the next line shared array colon and then your boxy thing or something weights.
Okay.
So in other words, you've got matrix size, blah, 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 and then shared array. We could say from shared array. Is that crazy? Or shared as weights?
The other place to put it, and there will often be quite a lot of space to put it, so it might not disturb so much the size, is in the key of the table rather than the value.
You mean here?
Yeah. So like weights, open bracket, shared as W. Because the value hasn't changed.
Yeah, you're right. You're right. You're right. That's a better place for it. I think your box thing is okay. I mean, I think that actual box should be grayed down, but other than that, I don't see a fundamental problem with boxing it like that.
I just hate that it makes the lines a bit higher, you know? Like it adds a 1.5 line.
They make it italic.
Okay, cool. Yeah, I like that. I like that solution.
Okay. So, okay, so it'll look like that then. Weights shared as weights, blah, blah, blah.
Right.
Okay. Now, but your kind of overall declaration of shared things, you are suggesting that somewhere, where are you suggesting putting that?
I have an idea here, which is that as we pile more and more information, like the net information stuff is very useful. It
Yeah,
would
by
be
the way,
nice.
that information doesn't have properties for shared arrays yet, and it's going to need those.
It does.
Okay, but that needs to be documented.
It is.
Did we document it?
Yes.
Really?
Yeah.
Okay. Okay. All right. Okay. So what is your idea?
The more information we pile on, and there's almost different kinds of information. There's the list of layers, right? There's the sort of like summary stuff, like the total amount of the mix of different layer types, all the stuff that's in net information.
Yeah.
And then the drill down type things like the actual names of the shared arrays. This to me suggests that we need a little browser that's a bit more sophisticated than just dumping it all at the same time. So imagine something that's maybe tabbed. Like you can switch
tabbed
between the list.
interfaces.
I mean, not with our actual tabbing, because I agree our operating system level tabbing looks cruddy.
Yes.
But
no, I
don't
hate
see
it just because
you
people
can
never
put it
notice that the tabs are there.
Yeah. Because you see that dead space that's under the icon, that could even be a switcher.
Yeah. Well, I think this is for the future. I think right now the solution of shared as whatever is okay for specifying the sharing.
All right.
And that would be similarly, that would work in a single layer as well. Am I correct?
Wait, it only works in a single layer. It doesn't work in NetChain.
No, but I'm saying when you go, okay, fine. Yeah, okay, all good. Right, fine. And then in NetChain, so you wouldn't see the sharing until you actually go down into the individual layers.
Right.
Okay, that's okay for now.
Okay.
All right, what's next to look at? And Jeremy, let us know if you're ready for us to look at your stuff.
Yeah, I have something I could show.
Okay. Shall I go to your? Do you want me to look at your screen, or shall I go?
That's fine. I can share my screen.
Okay. Go ahead.
Oh, that looks really cool.
Yeah, I think well, at least when they're alive, having color seems good. And then this would be I need to add in the, uninitialized, but it's more dramatic when it goes gray.
And then what does the graph one look like? Is that
I haven't gotten to that yet. This is going slow, so I need to work on that. But it'd be some more innate version of these, smaller pieces with a nice.
Well, so are you're suggesting those three colors in particular? That's kind of the flag of the neural net at this point.
I think so. Yeah, I mean, I like the green because it's kind of in our repository, and that's a huge shift, starting there, which kind of works. And Tally was using these colors. I don't know if they make sense per se.
Yeah, I think it's fine. I mean, it's kind of like it's like the yeah, I don't think that really works.
Yeah, I can throw that one out.
Okay, looks good. I mean, if anything, you might go a little bit narrower with the individual rectangles to avoid perhaps to make it. Well, I don't know. I don't have an opinion. I think it looks fine. How many of these? I'm just a little concerned about color because we haven't used color very much in these summary boxes, have we?
We're using more, so active things usually have a little bit of color, not multicolor all the time. Usually it's like a blue would mean it's in an active pod, with,
okay.
All
right, listen,
so it's not unusual to have color.
Just a slight preference to narrow each of the rectangles up a bit.
Yeah. So the other thing to keep in mind is we've got this word to deal with, and if it's going to be readable, I'm going to have some width constraint on on how wide it needs to be.
Yep.
I haven't gotten there yet.
Okay, fine. Well, just moving those guys apart or making them narrower, either one would probably serve fine.
Yeah, I could use some air with the arrows anyway. Okay.
Fair enough. Yeah, I think it's nice. I mean, yeah, it looks good. And I mean, you use similar color palette for the, but probably at least one more color in the. I mean, I think you want to have a slightly different. You know, you can have similar colors, but at least one more color in the graph.
Yeah, sure.
Okay, sounds good.
Yeah, that looks really nice. Can't wait.
Okay.
But I had an idea while we were talking. I hope I didn't forget it. Oh, yeah. So as a way of getting, look, the big problem that we still haven't solved with the state of play we have now is that if you have a chain, there's no indication that any sharing happened, right, after you've produced shared arrays. What about the following idea? What about some tiny hint that happens after the linear layer or the ramp? Well, it wouldn't be ramp, it would be linear layer, that indicates that within that somewhere is a shared array.
Yeah, right. So something more like, you know, one of these arrows that you use for a symbolic link or something. One of those, the things that, you know, like an arrow up to the top right or something.
Yeah.
Do you know what I'm talking about?
Well, which icon would this show up on?
Not an icon at all. It would simply be a glyph right after the word linear layer.
Oh, okay. Yeah, we can work on that. I mean, ideally, it'd be a font character. It really should be. Maybe we can find something.
Well, I mean, what I would have in mind is something that is more like one of those little arrowy. I didn't draw it very well. Does that make sense? Something like that?
Yeah.
There are a bunch of Unicode things for this. Let me look around and see if something. Yeah. Or if Jeremy can do that as well, that's fine. But
yeah, I can look too. Ideally, it'd be a character though. That'd make it a lot easier to deal with. If we can't find that, then we can make some kind of graphics object.
Well, let's see if we can get a character. I mean, look, worst case is it could be a grade. Simply, let's see, what would it be? If we just
Here's another idea, right? It's a variation on that idea. But yeah, let's look through for a bit.
Well, I mean, like that guy.
Yeah, that gets close.
Just a gray version of that thing there.
Yeah. So a variant of this idea is something that we would do in more cases, which is we have a glyph that says if there are any arrays at all. Okay. I think that's quite nice to have because it tells you what the point of the, if you've got a net chain,
is it doing whether it's trainable or not.
Yeah, whether there's and we have this red idea, which is very useful. It tells you if something is uninitialized. But really what that means is that it has arrays that aren't initialized.
By the way, how on earth does that red correlate with the red that you're using for layer coloring?
No, there's no correlation. It's merely correlates with the uninitialized text that you see that's over the icon.
No, I understand that. I'm just asking, it would be nice, given that red is indicating it's got weights, but they haven't been set.
I see your point. Yeah, we should try to theme that. So if we have this little icon that represents weights, then all we got to do is have a different color for it that represents shared weights. Or maybe it's got that arrow next to the weight.
Well, but by weights, I mean, basically, look, in a perfect world, this icon here, the neural net sort of connectivity icon, right?
Yeah.
The perceptronish icon, whatever you call it, could be, which is sort of a W. It has the kind of the motif of a W, he says.
Of a weight, yeah, W for weight.
Right. That becomes a tiny little glyph here. And that then the layers that don't have weights in them, here's a suggestion, okay? So just like there's that layer, so if I say, what am I saying? If I'm saying like linear layer here, okay, so this is a layer with weights. Oh, come on. I have to net initialize it. That's a layer with weights, okay, with a little bit of a W look to it. Jeremy, you get what I'm saying?
Where's your mouse? I lost your,
Here.
I'm looking at your screen. Okay, yeah, sure.
Okay, so that thing has weights. So now we want something which is a layer. So what kind of connectivity is there typically in layers that don't have weights, guys?
They're normally structural operations that are like, a lot of them have a one-to-one mapping to Mathematica function, Wolfram language functions, you know, flatten, reshape.
Okay, but what could we do to indicate, because here we've got this kind of everybody's connected to everybody type thing. I mean, maybe we could have a thing where it's more like for that icon, it's more like, I don't know whether this is right, but I mean, something, actually, how about this kind of thing? More like, an idea, more like that or something, which doesn't indicate that everything's connected to everything.
Looks like a Roman numeral.
It does, doesn't it? And I was thinking,
But it's
you
the
want
size
to,
of a character? How big is this thing?
no, I mean, that's the icon in the case of, that's this icon here.
Oh, the layer
Then that
icon.
would
Okay,
be,
yeah,
but
sure.
then it would be iconified. Something, a simplified version of that would be iconified. Look, forget this part here.
Hmm.
Okay. What do you think about that X as an indicator for a fixed? I mean, it would be nice.
I hate the idea of even using the iconography of neurons for something that's not.
Okay, well, what kind of thing would you like? Would you like a square bracket thing? I mean, it's.
You know the icons people use for like the sigmoid function?
What do those look like?
I don't know, like a little, like a stylized S. It's mathematical. It's, you know, like an F or an S or an arrow, something that doesn't have any connotations of neural.
Well, I mean, then no, but you're oh, great. We got pictures of the sigmoid colon as well as the sigmoid function. Oh gosh, I hate these.
It's like it's an S shape with a circle in it, but that's not the point. That's not what I'm really saying. I'm just saying something that feels more mechanical and that breaks the whole analogy with biological.
Well, okay, so I mean, one possibility would be some kind of, I don't know, circle type thing with a
arrow going in and arrow going out, maybe.
What are you suggesting? You're suggesting some kind of thing, because we do want to get, I mean, maybe it's something like this. Yeah, I think it's useful to have the ports there. Okay, so that would be my suggestion. Something like this where there's an open circle or a gray circle there or something.
Okay.
Yeah.
Yep.
Okay.
It could also be a square, which is a more mechanical shape than a circle, but yeah.
You could, since we're talking about float, yeah, that's a layer. Since we're talking about flowcharts, you could have a parallelogram. I can't remember what a parallelogram is for, yeah, something like that would be okay, maybe, or a diamond.
Mm-hmm.
I agree.
A diamond, actually, a diamond might be the better thing.
Yeah, I like that. That gives you a kind of, even if I'm thinking the ins and outs are stacked, so the end's a little higher than the out, you know, towards the middle of the angled side.
Okay, I don't get that. So you're saying that this, you're saying maybe, more like that?
Maybe. It's a little weird. It feels.
It's a little weird.
Yeah.
But okay, so if we did that, then the suggestion would be that that becomes iconified as a thing that would be next to the layer type here, possibly on the left of the layer type. And that normally what would happen is that you would have a little tiny icon there that would be a tiny, you know, some tiny version of the neural netty thing that is sort of a, you know, whatever it is, this thing here, right? A tiny version of that or a tiny version of this other guy. And then that in the case where there is a shared array, there would be some kind of arrow thing indicated on top of that. Did that make any sense?
Or next to it if it's too cluttered, perhaps.
Next to it isn't going to work because it's going to change the alignment. Right, because the idea would be this is on the left, reading down the left edge here.
Okay.
One would assume.
Definitely the type. The shared could be a column, you know, to the right.
You mean to the right of the name?
Yeah, yeah.
Yeah, it's possible. All right, so that's so getting really small icons for that is a thing. Probably.
Well, then
not
the obvious thing is that those little icons, do they? Oh wait, and those little icons, they don't mean they're not representing the type of the layer that's right next to them. They're representing whether the layer has any weights at all or not within it.
Okay.
Right? I'm asking.
Well, yes,
Yeah.
I think that's correct. Which means that probably what wants to happen is, you know, there's a certain argument that what should happen is that there's a little icon to the right. There's two little icons to the right, like you know, when they have you know, like when there's a freeway exit and it's like, you know, there's gas and there's food and there's whatever else.
Yeah.
Or is that only European ones that have just the signage? I can't remember.
No, we have that.
What's the we in this case?
I don't know, South Africa.
Oh, okay, fine. But you know what I'm saying, that there's a image of a yeah, so that what I'm suggesting is that you have like the, you know, food, gas, hotel type images that indicate whether there are weights underneath, whether whether it's shared and so on.
That's actually what I meant originally. That's
okay.
Yeah.
Fine. I agree. All right, listen, we got some other things we've got to cover and I've got to go in a few minutes. So I think that's it for Jeremy here, so far as I know.
All right, sounds good. I'll go then. All right,
thanks.
Bye.
Okay, bye-bye.
Cool. Thanks.
Okay, so what else do we have to cover here? You've sold me on this NetSharedArray thing. What else do we have to cover?
So scroll down a bit because it's actually shown in one of those examples and the page for it is a stub anyway. The common case is when you have something like an LSTM and you want to share all of the arrays at once, okay? So you're not going to be typing in, I don't know what it is, it's like 14 different arrays or something. You're not going to be typing those in. You're going to just do a bulk, you know.
So that's the analog of NetInitialize.
Yeah. In a sense, yeah. So we could try to fold it into NetInitialize. That's one possibility. Problem with that though is that you can still share things that have been initialized, right? The weights will just be carried along in the sharing process.
Carried along. They will be locked to each other. What do you mean carried along? I mean, if you've initialized the whole sequence, then you're resetting those weights in order to share them.
No, you're not. Like take that LSTM, right?
Yeah.
You initialize it. You've now got concrete values for all 13 of those things. Then you do a global share operation. All that means is that you move them along to be global. They're still concrete. They're now global. And what they left behind pointers inside the LSTM. Hey,
by the way, somebody on our live stream, I can't pronounce these usernames. XUMX, XUMX, suggests an idea for train weights, that the edges and the W icon could have varying thickness.
Okay, that's interesting.
Yep. I mean, or they could have some other. Well, the question is whether, yeah, I mean, I like the very bold, uninitialized, this isn't going to work type iconography, but that is an interesting idea for in cases where we have to indicate it in a less obvious way.
Yeah.
But, I'm sorry, back to the nationalization thing. So let's see. So we're saying the question is, when you're doing the sharing, if you've already initialized, all the weights are already random values of the weights, and then you go along and say, okay, share all of these, aren't you just, you know, aren't you yoking these things together somehow?
No.
What do you mean no? I mean, if you've already got these separate arrays and they're separately initialized and they're all random and different, what then happens?
Because that share arrays, you should open the doc page, because I didn't really say how it works, but what it does is it takes every array in the net and it shares each one uniquely. It doesn't like make them all be the same. It just makes them each have their own net shared array.
Okay, but so what? Then what's the purpose of that? So that you can share it with another thing that you're going to add?
The reason for it is this is extremely common. This is actually the most common way that you use this feature, is that you take an entire layer or even a bigger construct, make it shareable, make it shared with that net share arrays, and then every time you use it in a bigger net, it will make it the same thing. Normally, if you made an LSTM,
I get it. I get what you're saying. I get what you're saying. So which is not what I had in mind from the name NetShareArrays. So what that means is, given a layer, you want to add sharing annotation to every one of the arrays here, so that were you to copy this layer, when copied, would be copied so that its arrays are shared with the copy.
Yes. So we need to figure out a name for that, because I mean, even if this name was good, it's also too similar to NetSharedArray.
No, I agree. So what this is, I mean, it's basically set the arrays to be shared arrays. Whatever this thing is, what the heck should this be called? So this is something where you want to annotate the arrays as share on copy, basically. That's what ultimately is going to happen, is that were this construct to be copied, you would want the arrays, I mean, they're really shareable arrays somehow.
Yes, they're shareable arrays.
Except that they are. Okay. Well, there was a third thing, and because I'm going to have to go in a moment. There was a further thing that you.
Append layer. Just you can bring. I mean, it should be a pretty slam dunk. Luckily, because we have the language that is set append layer.
Well, there's one, append layer.
It's just called an append layer.
Yeah.
And appends another tensor. Well, what do you mean by appends? You mean appends in the same way that join with that append?
Yeah, it's exactly like
join layer. Given that it appends an element to a list, joins two lists together.
Correct.
Yeah, so I should probably
join layer.
Well, because join can take arbitrary numbers of arguments, and
so what? Append takes a big thing and a little thing.
Yeah.
That's exactly what this does. This is append, really.
It's append.
Okay, fine.
So the only question was, what the other argument is. Well, there's two arguments. There's an input and there's the element that you're appending.
Yeah, we got to name them. So what do we call them?
What do you mean naming them? I mean, I see.
The ports.
Well, why aren't they called? I'm sorry. I mean, there's the appendee, so to speak. That's what you're.
that's what I suggested as a joke, but
yeah, it's silly. Why is the first one called input? Is that just a standard name for that?
Yeah, it is.
It doesn't seem terrible. Input and element doesn't seem terrible. Element seems the obvious thing for the appendee, so to speak.
Okay.
All right. Let's come back for a moment to the NetShareArrays. Okay, so what this is going to do is to make every array here. I don't quite understand. It's going to replace the array in the actual network with a NetSharedArray, and then where does it give? How are the values of the NetSharedArrays specified? Where are those given?
They were whatever they were in the net. So if the net was initial,
yeah, okay. But in the actual structure of a net layer, doesn't it replace the weight matrix? What does it actually look like in the association that represents the actual layer? Does it say weights arrow shared, net shared array of blah, instead of saying weights arrow some big matrix?
Correct.
Okay, so where is the payload? Where are the actual matrix of weights?
Yeah, the global array, the global shared arrays are always global, right? That means they're always in the root of the association. So there's another key in the base of the association called shared arrays goes to, and that's an association of name goes to matrix. That's true of all. That's how sharing works. Is it just
Yeah,
always?
But how does it get to the root? It gets to the root of the net chain, and then it floats up to the root of the net graph if it can.
Yeah, it always floats up to the top, no matter what the top is. Exactly. I mean, users don't care about that, right? They just know that
eventually it floats into the net evaluation function. Is that true?
It's a strange question. I mean, I don't.
How far does it float up?
To the root net.
Okay, but I thought the root net could be the net evaluation function. Yes.
It depends how it's implemented. Like there may be benefits to doing it that way, or may not be.
All right, okay, fine. But then, okay. So the issue here is, I mean, NetShareArrays is not the worst name for what. I mean, it's kind of a weird concept. Let me see. What you're doing is you're making the arrays be shared. I mean, look, other names that I can think of, which I don't really like very much, but they're names like, net set array sharing. It's pretty awful because it's not really setting anything.
The difficulty with this name, NetShareArrays, is that it could mean something else, which is, I think, what you first thought.
Well, that's what I thought it meant.
Taken an existing network and introduce sharings within it.
Right. This means it means recode it as shareable arrays.
Yeah. But I think there is good news, though. I think that we could have a spec for the second argument that does both of these things. And the current meaning would be, being a little bit loose, it would be all goes to automatic. In other words, take all the arrays.
Yeah, I get it.
And share them as unique. But you could do other things, like you could give a list of weight 1 and weight 2, and I want them to go to weight.
Yeah, I mean, look, currently what you're saying is share them for the future as opposed to share them in the present.
Yeah, exactly.
What's an analogous situation? Someone is suggesting share array properties. No, that doesn't really work because these are not properties in the usual sense that we use the name properties. Net insert shared arrays.
Yeah, it could work.
Net use shared arrays. Unfortunately, use, but it's read as net use shared arrays.
The correctest but clunkiest way of saying it would be net replace with shared arrays. Because it is a replacement, right?
I get it. Use, insert. Let's hit the thesaurus for 1 second. Probability of success low. Let's see. Let's see. Include. Introduce. None of these are great. That's more like the net introduced shared arrays is like, you know, one of those at some fancy event.
Yeah.
Now presenting, whatever. Let's see. Do you think this form is correct? Net, blah, net, verb, shared arrays. Seems right to me. Because that way it doesn't, then when you have a net shared array inside the thing, it's unsurprising that net, verb, shared arrays put it in there.
Yeah.
Well, is it inserting shared arrays?
I think it's fair to call it inserting shared arrays. I mean, what feels odd about insert is that it doesn't emphasize the displacement. There's a displacement going on here.
It isn't a displacement. There is no displacement. In the automatic case, where the thing is merely, you know, tagging itself with shared arrays for the future, it is merely an insertion.
Yeah, but if there were raw arrays there, they don't disappear. They just become shared.
Well, they become shared in the future.
Yeah, in the future, sure.
Well, that's more like use shared arrays.
Net use shared arrays.
I hate it because they'll be read as net use shared arrays.
Net.
What about net tag shared arrays?
No, because it's like there are shared arrays there and you're just deciding whether to tag them or not.
Apply shared arrays, apply sharing. Deploy shared arrays. Bleh.
No, we've got too many other meanings to deploy. Employ shared arrays. We never use employ for anything, but that's really weird. I mean, that's more like an option name, net employ shared arrays. But I don't think we've ever used employ for anything at all, ever.
I mean, the thing I find least objectionable is insert shared arrays. It's not quite the right meaning for me, but let me use the thesaurus quickly.
Well, the other possibility would be a more general, you know, which might be the thing for the future, a more general, you know, net optimize function or net, you know what I'm saying? Some kind of net optimize, net set. I mean, because I can imagine in the future, like, for example, if you wanted to compress a network, right, you might want to say net optimize in certain ways, or net, is it really optimization net? You know, it's set a net structure in certain ways. You might want to do that.
Yeah, I know, but I think they're going to want to have very different options and things. I don't think they're going to.
All right, listen, I have to go. I think you should put in net insert shared arrays. Let's see how that works. We're going to need to do one more check-in, presumably before the freeze, to go through some remaining documentation issues and to pick up whatever Jeremy has come up with.
Cool.
All right. Did I save anything out here? Do I need to push back documentation stuff here?
Honestly, I don't think you did.
Okay. All right. Well, to those who've been listening on the live stream, thank you, I guess, for listening, and expect cool new symbolic neural net functionality as designed here showing up in the system real soon. Okay. See you all soon.
Thanks. Bye.
Bye. Bye.
Bye.